Medium efficiency HVAC filters, often called pre-filters. What do we mean about medium efficiency? Well, medium efficiency typically is referring to a filter that's Merv-8. Sometimes fiberglass, polyester, bulk media rolls and pads, metal washables are lumped in here, but because those are not nearly as efficient as Merv-8, really don't consider those medium efficiency. Just a quick note about medium efficiency. Now, Merv-8 is really designed to protect high-efficiency filters that aren't designed to handle large particles and equipment. It is not an adequate filtration level for protection of building occupants. As you see in the graph here, that little red box in the corner is what Merv-8 catches compared to the typical particles that are found in air. So it really doesn't catch any of the harmful stuff, and it catches so little of the particles that are in ambient air. Again, high efficiency filters should be used in every application to protect building occupants. Merv-8 simply to protect equipment or make high efficiency filters last longer by protecting them from the large particles. Your options when it comes to medium efficiency, you've got three main kinds: ring panels, pleats, and cubes. Within pleats, there's more options within that style, as self-supported, standard, and high capacity, and high velocity pleats. And then sometimes we'll see antimicrobials or charcoal added to these styles of filters. So ring panels, they're inexpensive, they're incredibly durable. We just don't see structural failures of ring panels because of the media that they used and the way that they're made. And the big talking point with them is they're linked to lower or eliminate bypass, again, with what little percentage of particles were taken out of the air with Merv-8. The real life benefit of having no bypass is questionable. The problems with these filters is they have very high static pressure, which means you're paying the most energy to pull air through the filter itself. Very short filter life. They rely very heavily on tackifier. Once that loads, the efficiency is compromised. The limited amount of media support, that is, the way they're designed is they have a metal wire around the perimeter of the filter and then maybe one or two support bars in the middle of the pad of media. That just lends itself for the media doesn't fail, but it'll start to bow and stretch out, and then as it stretches, the particles get stretched farther apart and the efficiency goes down. They have the lowest amount of media per square foot of filter of any of the Merv-8 options, which is why we have the high static pressure and the short filter life. And from an installation and removal standpoint, this media just tends to catch, because it's a lofted media, it catches very easily on bolts and rivets and stuff that might be in a filter rack. So it can make taking them out and put them in quite difficult. So self-supported pleats are kind of the next step here. Very cheap, which is supposedly a good thing. And because they don't have any metal, they're incinerable, so it opens up another disposal option for you. Problems with these is they're just structurally weak. Without that metal support, they're very prone to blowouts, especially when any kind of moisture, humidity is exposed to the filter. They have very short life. Again, once they start to load, it cuts off airflow to the filter, and they start to bend and bow and blow out because now the more static pressure is exposed to the filter. They were designed to be the cheapest Merv-8 that you can purchase, so just kind of keep that in mind. The design of the filter was to be cheap. When you design something to be cheap, you give up other things to achieve that goal. The performance is the big part of that. They don't handle high CFM well, and extended periods of moderate CFM they also kind of struggle with. So standard and high capacity pleats, these are the absolutely most common Merv-8 pre-filters that are in use today. Beverage board frames, wire support. And why are they so common? They give you average lifespan and average cost. So they're kind of that happy middle place where everybody kind of just congregates to. It's not the cheap crap, but it's not the expensive, really nice stuff. So we just kind of migrate towards the middle, and this is the middle. just a quick note on standard versus high capacity. Standard capacity has 12 square feet of media usually for a 24-24-2. That same size filter in a high capacity has 17 square feet of media. So a high capacity has about 30% more media than a standard capacity. The trick here is because you're jamming so much more media in the same amount of space, that media can essentially pinch itself off and you won't have airflow through that media, which means you have 30% extra media, but it doesn't necessarily mean you're going to get 30% extra life. High velocity plates are kind of the top of the line when it comes to Merv-8 efficiency filters. Pioneered originally by the FAR 3030, some other manufacturers are starting to kind of copy it. These filters are just built better. They use better, stronger support on the back. The FAR 3030 actually uses a welded wire. You have stronger, tougher boards. Some cases, like with the FAR 3030, it actually will repel water a bit. The medias can be different. The FAR 3030 media I know is completely different than anything else out there. And a lot of times there's changes in medias with other manufacturers as well to just be able to handle higher volumes of air better and hold more dust along the way. So it's just the best of the best. It's incredibly durable, so you have a strong performance. It's a high dust loading, and it'll offer the lowest energy use typically among other options at Merv-8. The FAR 3030 remains the only Merv-8 filter that has a performance guarantee. The downside of this is we're using better materials across the whole design of it. Those cost more, so the filter costs more. Cube filters are a pretty good option for Merv-8. They're very durable. It's basically a ring panel media in the same kind of design, same kind of frame, but we give it extended surface. So you get longer life, higher dust holding capacities. Some manufacturers actually put a metal header around the outside of this to make side access tracks easier to install and remove the filters from. Problems is they cost quite a bit of money comparatively to the other Merv-8 options, and you need 15 inches depth downstream of the filter rack. So in a V-bank style filter rack they wouldn't work because they'd bang into each other. That extra space is crucial for this, and a lot of times you just don't have that in a pre-filter situation. Popular add-ons are antimicrobial. That's probably the biggest one. We see it a lot in ring panels and cubes. For some reason it just seems to be in those products the most. However, ASHRAE published a study some years ago in their journal that says there's no benefit adding antimicrobial to air filters because filter media itself is so inherently hostile to growth. And then once it loads, the debris that's loaded in the filter, if that's going to grow mold or other spores, it's going to do that because the debris wasn't treated with antimicrobial. The filter was. Charcoal is another common thing. Some folks actually call these carbon pleats. It's most common in pleated filters. It'll alleviate minor odor issues. Sometimes you just have such a low level of charcoal that's in here and you don't really have any kind of bed. It's just embedded into the fibers. It's not a very efficient use of charcoal just because of how charcoal captures those odors. Sometimes it works, sometimes it doesn't. So just a quick recap, you have a lot of different options out there for medium efficiency, more than I think a lot of people realize. You do have to kind of take Merv-8 and medium efficiency with a little bit of a grain of salt and just be aware it's designed to protect better filters and it's designed to protect equipment. High efficiency filters need to be used to protect building occupants. Merv-8 is not adequate enough to protect building occupants. Use of antimicrobials on filters have no value, and that's not just coming from me personally. ASHRAE has their studies that have backed that up. Charcoal embedded pre-filters are mostly useless. They work sometimes. It's just a lot of the times it was a temporary source of the problems, and by the time you put the charcoal filters in, that odor source has left, so you don't have it anymore, which makes it appear that the charcoal is doing something, but a lot of times it's pretty worthless. Biggest considerations with Merv-8 filters, as any other filter, is how much energy does it take to use? What's the life expectancy of the filter? How easy can we put it in and take it out? Is it going to hold up during that lifespan to get the most dust holding it can out of it without having a structural failure? And again, how much does it cost initially?